our viewers, wherever you are watching us from. I do welcome you to our online channel at Steve Getao at 660. I am your online teacher, Mr. Steve Getao. In our today's lesson, and a series of more to come, we shall examine preparation of gases in the laboratory. Later on, we shall examine other practicals that are done in the chemistry laboratory. Welcome, and let's get started. In preparing hydrogen, you require a set of reagents. Preferably, we may use zinc granules and hydrochloric acid. Zinc is a relatively moderate reactive element, or you may use slightly more reactive, but not very reactive, magnesium. You find that when zinc is used with dilute hydrochloric acid, you may need to make the reaction faster, and there you use copper sulfate as the catalyst. So I may want to show you, we have a conical flask. Into it, you press some zinc granules, you fix it over here, and you may add some copper sulfate as a catalyst. Copper sulfate serves as catalyst. So zinc granules, this is a catalyst. It's not a part of the reagent, it's just to fasten or to quicken the rate of reaction. However, I would prefer that we use another metal, that is magnesium. So I have some magnesium granules here, which we shall place in the conical flask. So we place some here, the conical flask, that is magnesium pieces of magnesium, we call it magnesium ribbon. We have some cut magnesium ribbon, cut into small pieces, and we place them in the conical flask. We fasten so that we do not have any leakage of the hydrogen gas, and then we ensure that the setup is okay. We are going to have a drop-in funnel modification or modified. So this is going to be these two funnel will serve as our drop-in funnel. We add HCl, and the first few bubbles we shall let them escape, because the hydrogen that will be produced in the first few minutes or seconds will be mixed with oxygen. So we let that mixture escape, and then after a few seconds we correct the hydrogen. So let's go. We add HCl, we add our HCl. Already you can have bubbles there. So we cork that point, and we are going to correct with a boiling tube. So we fill it with water, and the moment it is full, we can then correct our hydrogen. We correct our hydrogen, and there we go. You can see the hydrogen displacing the water. This method of correction, we call it downward displacement of water. So the first boiling tube is full, so I cork it, I place it on my rack. We get another boiling tube full of water. We correct more. This will be used for our subsequent experiments. So let's correct more hydrogen. We are displacing the water. The hydrogen that we correct, we call it wet hydrogen, because it's corrected using the overwater method. So our second boiling tube is almost full. So I need to cork it. we need to cock that. We may correct the last one. Let's see if we still have some more that is coming up. Now, as the magnesium gets exhausted, the rate at which hydrogen is produced becomes slower and slower. I believe by the end of our discussion, this one will be filled. So, viewers, basically that is the setup. We may have the Visto funnel here, preferably replaced with a drop-in funnel, which has a tap to regulate the amount of hydrochloric acid that we have put. Now, some of the characteristics of hydrogen that we are seeing here is that hydrogen gas is colorless. It's a colorless gas. It has no particular color. Two, we see that since it is possible to correct it over water, it is not soluble in water. At times we say it is only slightly soluble in water, meaning only a small portion of it will dissolve in the water. Now, let's look at several items in our discussion. Number one, we have talked about this set of reagents whereby zinc and hydrochloric acid may be used, and the products are zinc chloride, which serves as our salt and hydrogen gas. In case for our experiment, we have used magnesium. It has reacted with the hydrochloric acid, and so we have gotten magnesium chloride as the salt, magnesium chloride as our salt, and hydrogen gas. We get our hydrogen gas. Now, later on, we may be able to write the symbolic equation for this reaction. The symbolic equation would be, we have magnesium in solid form reacting with the HCl as a solution, and we get magnesium chloride. We have a capital C, which is soluble, so it's aqueous, and hydrogen gas. Now this equation requires balancing. There are two hydrogen atoms there, so we put a 2, and the chlorines are 2. So that gives us the balanced equation for that reaction. Now let's look at item number 3, the mode of correction. We talked about when the gas is to be corrected dry, we have upward delivery, also known as downward displacement of air. You correct it by displacing the air downwards. However, when we need it, or when it is corrected as wet, like the way we have done it here, we have overwater method. Also, we can refer it to as downward displacement of water. Downward displacement of water. Now, let us move to item number 5. How we test for hydrogen. So viewers, you realize that when hydrogen is mixed with the air, the hydrogen and oxygen mixture will burn with a pop sound. So let's test on ours and see how that one occurs. We're going to use a burning splint. So you're going to use a burning splint. It's a burning splint there. And so we're going to open and introduce the burning sprint onto the mouth of the hydrogen. So let's get going. That's the pop sound. The pop sound. It is good because this test should not be confused with other gases. For instance, hydrogen does not support combustion, meaning if we put a glowing sprint into a gas jar full of hydrogen, the glowing sprint does not relight. Let us see this one. So I want to redo this one. So we create a glowing sprint and we introduce it there. You find it does not relight. However, if, for instance, we introduce a burning sprint, we expect it to relight. Let's see if there's still some hydrogen left here. Yes. So we still have the hydrogen. So that creates the difference. This is a glowing sprint. There is no flame. It does not relight in hydrogen. That's the point that we are making at this level, that it does not support combustion, but only burns in air. Now, let's come to this point here. Why the pop sound? The pop sound is due to the hydrogen having been mixed with oxygen. Otherwise, we say that pure hydrogen burns with a blue flame. It burns quietly, it burns slowly with a blue flame. So that is very, very important. We revisit properties of hydrogen. Number one, we find that it is neutral, meaning it has no effect on the litmus paper, and it is neither acidic nor basic or alkaline. It is not alkaline, it's not acidic, it's neutral. Now, we had made that point on the fact that it does not support combustion. It does not facilitate the burning process. Number three, we talked about it being insoluble in water or just slightly soluble in water. The percentage that will dissolve is very small. So we say slightly soluble in water or insoluble in water. Both are acceptable. Let's look at methods of drying hydrogen. How do we dry hydrogen? In our setup here, we have prepared wet hydrogen. If it were required dry, we would use some drying agents. The drying agents to be used in this case are either we bubble it through concentrated sulfuric 6 acid. This will dehydrate the water. This will remove any water that is there, any moisture that is in the hydrogen. So bubbling it through concentrated sulfuric acid and then correcting it by the upward delivery or downward displacement of air. And the other way of correcting dry hydrogen, or another dry hydrogen, is through passing it in a U-tube that has been filled with a drying agent called anhydrous calcium chloride. Anhydrous calcium chloride is a very suitable drying agent for hydrogen. So either of the two works very well. Now viewers, we may lastly discuss on what are some of the uses of hydrogen. Number one, we have hydrogen being used as a reducing agent. We say that hydrogen can reduce metal oxides that are below it in the reactivity cells. Talk about metal oxides like copper oxide, lead oxide. Those two, and even iron 3 oxide, can be reduced by hydrogen. What is reduction? Reduction is where one element is able to remove oxygen from another element. So when hydrogen is passed over some heated copper oxide, the oxygen in the copper oxide is removed by hydrogen, leaving copper metal, and the hydrogen has been oxidized as hydrogen oxide, which is called water. 2, we also use hydrogen in large-scale preparation of ammonia in a process called Haber process. Hydrogen is also used in hardening of oil to fat, a process called hydrogenation. Then we also have hydrogen. This is becoming rare and rare, whereby hydrogen is used in the hydrogen balloons. This is becoming a little bit rare. Now we also have hydrogen being used in hydrogen frame. This is a frame that is quite hot in the temperature range of about 2000 degrees Celsius, which can be used in welding and at times cutting metals. So in a nutshell, those are some of the uses of the hydrogen, both industrially and maybe from a local or small scale perspective. So viewers, today we were examining on how hydrogen can be prepared in the laboratory, what are some of its properties, and what are some of its uses. And we are saying in summary that you need a moderately reactive element taking zinc or magnesium, react it with an acid, and you will be able to prepare hydrogen and then correct it appropriately. But we have one question. Why is hydrogen corrected by upward delivery or downward displacement of air when it dry? This is because hydrogen is lighter than air. Its density is lower than that of the density of air, meaning it will float on air. 2, when we generalize and say a suitable metal reacting with a suitable acid, we have question number 2. Can we be able to explain why nitric acid in dilute form is not suitable in preparing hydrogen gas? So take time to search on that. You can pause on the video and discuss it out, and then you come back to the video and see the answer. Viewers, the answer to that is that nitric acid is not used to prepare hydrogen gas because it oxidizes the hydrogen produced to water. Because of the oxidizing property of nitric acid. Nitric acid is an oxidizing agent. It will oxidize the hydrogen by giving it water, by giving it oxygen, I beg your pardon. So nitric acid gives the hydrogen gas produced some oxygen, and instead of the end result being hydrogen, we correct water. So you find that nitric acid is not suitable in the laboratory preparation of hydrogen. So with that, viewers, we come to the end of our discussion today. I would like you to comment on this video, like it, share it, and let us meet in our next lesson at Steve Getao 3660. Thank you.